Hello, I'm Dr. Priyanka Gautam and I welcome to the course Environmental Monitoring and Instrumentation. Today, I'll introduce the key aspects of this course, which includes its objectives, structure, learning outcomes, as well as its place in National Credit Framework, NCRF, and related career opportunities. Moving forward to the course objectives, the primary goal of this course is to give you a comprehensive overview of environmental monitoring methods and instrumentation. We will learn to measure, model, and assess parameters of environmental quality for environmental risk assessment. In particular, you will study how pollutants are sampled and analyzed, how they move and transform in the environment, and how to use modern equipment for data collection and analysis. We emphasize both theory and practice. For example, we cover equipment selection, their use, data collection, and analysis, even providing hands on experience with monitoring instruments. By the end of this course, you will understand the scientific principles behind environmental monitoring and be able to apply them in real world. Next is course structure and modules. The course is organized into units or weeks, which means one unit will be covered per week, each focusing on major topic. Overall, there are 15 weeks of content. The first 13 weeks cover core subject matter, and the final 2 weeks are reserved for group projects and presentations. Now, the overview of each week is week 1 starts with the fundamentals of environmental systems. This lays the foundation for understanding how environmental systems are interconnected. Week 2 is about organic priority pollutants. We study POPs, PAFs, VOCs, followed by their toxic dynamics and global inventories. Week 3 is about air quality parameters. This covers criteria gases pollutant, matter fraction, and climate forcing pollutants. In week 4, we will study sampling strategy design, which includes statistical design of sampling and many more things. Week 5 would be all about laboratory analytical techniques like UV visible, double AS, etc. for pollutant detection. In week 7, we will study QA and QC protocols. In week 7, we will cover regulatory compliance, reporting, focusing on environmental regulation, SOPs, and electronic reporting requirements in the industry. In week 8, atmospheric transport processes will be discussed. In week 9, we will be covering air water exchange mechanisms. In week 10, we will be studying sediment water interactions. In week 11, multimedia fate modeling will be discussed. In week 12, we will discuss remote sensing satellite observation. Week 13 would be about environmental laws and case studies. And finally, week 14 and 15 would be about group project where students work in teams on an integrated monitoring project and present their findings applying the concepts learned from this course. Each of these units had specific subtopics and learning tasks. Overall, the course content moves from fundamental concepts to advanced tools and real world application, ensuring a logical and comprehensive learning progression. Now, moving forward towards the learning outcomes of this course. By the end of this course, student will gain both conceptual and understanding the practical skills. Especially, they should be able to explain the basic concepts of environmental monitoring, including source pathway receptor framework and pollutant fate and transport. They would identify priority pollutants and understand their behavior, design and justify sampling plans for air, water, soil, and sediment. They will learn to explain basic concepts of sampling, plan development, and strategy, and to perform sample collection and packaging in the field. Apply QA/QC protocols, interpret environmental data. These learning outcomes align with industry expectations. Now comes the NCRF level and employability after studying this course. This course is aligned with India's National Credit Framework, which is NCRF. This course is at the postgraduate level with NCRF level 7, which means it is recognized as providing that level of academic and practical skill. In terms of employability, the skills you acquire open up many opportunities. Students can work as environmental monitoring techniques or specialists in consulting firms, government agency, research laboratory, or industries with environmental compliance needs. Other roles may include environmental lab analyst, data scientist in environmental quality assessment, regulatory compliance officer, or continuing to research for higher study in environmental science. Moreover, this field is growing as there is increasing demand for environmental data to inform public policy and industry practices. Thank you for your attention. I look forward to guiding you through environmental monitoring and instrumentation course, where together we will learn and explore how to measure and protect our environment with the latest scientific tools. Let's begin our journey. Thank you.